Hi and welcome everyone, I'm Gavin Lon. In this video, we are going to look at 5 new features that have fairly recently been included in C#. I believe that it is important to keep up with the new features like these, even though often you can just use the old syntax to create the same functionality. The new features come with many benefits. For example, you can achieve the same functionality as before with less code. You can leverage greater power with less code. The new code is more concise in many cases and easier to read and maintain. As a C# developer, I believe having at least a basic knowledge of the latest features in C# is essential. If, for example, you are working with a team of developers, other members of your team may be using new C# features. If, for example, you need to debug code written by another developer, and the other developer has written the relevant code using certain new C# features with which you are unfamiliar, this can result in your instant expulsion from the C# developer community. Okay, I'm just kidding. But this can make you less efficient in some cases, so it's always a good idea to keep your knowledge up to date. So in this video, I've picked 5 examples to discuss of relatively new features that have been included in the C# language that may start to be frequently used in C# applications. Okay, so if you want to follow along using the new features discussed in this video, you may need to update your environment. You may need to download the latest version of the .NET SDK. You can do that from this URL. You'll need to do this if you are using Visual Studio Code as your code editor. You can download the latest version of Visual Studio Code from this URL, and this is of course free of charge. Or if you are using Visual Studio, you can simply download and install the latest version of Visual Studio from this URL. Of course, you are able to download the Community Edition of Visual Studio for free. Number 1, record type. So the record type was released quite a while ago. The latest version of C# is version 12, and this version of C# has just been made available with the official release of .NET 8, which was released last month, November 2023. So record types were first made available with C# version 9. Note that the new enhancements have been made to the record type feature with the release of .NET 10, but we are simply going to look at a broad overview of some benefits of using record types in C#. This is by no means a deep dive. Firstly, in order to get a basic idea of what record types are and how they can be beneficial, let's first look at how we might represent an employee record in code using a C# class. Prior to the introduction of the record type feature, you only had 2 ways to represent such data, either by using a class or a struct. Once we have defined the employee record using a class, we'll then contrast this with representing the employee record using the new record type feature. So let's start by creating a public class named employee. Let's create a parameterized constructor that contains 4 parameters. In Visual Studio, a quick way to generate code for a constructor is to type CTOR and then press the tab key, like this. And let's add the relevant parameters. The ID of the employee, which is an integer, the first name of the employee, which is of type string, the last name of the employee, which is of type string, and the employee's salary, which is of type decimal. In Visual Studio, we can quickly generate read-only member variables from the parameters included in the constructor, like this. We can then make the read-only values for these member variables available to call in code through the use of read-only public properties. And note how Visual Studio is making it easy for me to generate the public properties through artificial intelligence. So Visual Studio recommends the syntax through ghost text, if you like, and I can press the tab key to accept the text if it matches my intentions. And in these cases, Visual Studio is guessing the syntax correctly. That is super convenient. Great! So now let's create calling code to instantiate an object from the employee object. So when we run our code, by default, the type of the object, employee, is outputted to the screen. Let's create another object in code. Let's name this object employee2. And let's write code that writes the employee2 object to the console screen. Great! Now let's see what is outputted to the screen when we compare employee1 to employee2 using the double equals operator. You can see that the four values for the compared objects, employee1 and employee2, are identical. So surely employee1 is equal to employee2. So employee1 double equals employee2 should return true, right? Let's run the code. Oh, and it returns false. A class is a reference type, so when employee1 is compared to employee2, the comparison being made has nothing to do with comparing the four values, ID, first name, last name, and salary, of employee1 to the same four values in employee2. The comparison that is being made is whether these two variables, employee1 and employee2, are referencing the same object in memory. So in this case, employee1 and employee2 are referencing two completely different objects in memory. That is why false is being returned. If, for example, instead of instantiating an object derived from the employee type twice, where an employee referenced by employee1 is instantiated and another completely new object is instantiated that is referenced by employee2, what if we instantiated one object referenced by employee1 and then simply assigned that object referenced by employee1 to employee2 like this? So this means that both employee1 and employee2 are both referencing the same object in memory. So now when we run the code, the comparison of employee1 to employee2 returns true. Okay, so now we finally get to using record types. Let's create a record type to define a template, if you like, for an employee record. So now we are using the record type, the new record type that was released in C# version 9, to define our employee user-defined type. Let's call this type employee rec. So instead of using a class to represent the employee record, we are using the new record type feature in C#. So now, if we write the same comparison code, but this time comparing two objects derived from the employee rec type, which is using the new record type feature to represent an employee record, you can see that the result of this comparison returns true. So you can see that if we have a requirement to compare two employee objects based on the values stored within the objects, a record type is far easier to use for this purpose than a class. No additional comparison code is necessary. This functionality is all built into the record type feature. So the relevant comparison code is generated behind the scenes when a record type is used. This is not the case with a class, where if you wanted to perform such comparisons, you would have to add appropriate additional code. You can see that the code is also far less verbose than when using a class. For example, public properties are synthesized for each of the parameters contained within the primary constructor of the record type. A primary constructor is where parameters can be included with the type definition, as is the case with our record type here. Primary constructors have now been introduced for classes and structs, and this will be discussed in the next part of this video. Also behind the scenes, code is synthesized for the record type, where, for example, if you write the employee object to the screen, it automatically writes out the relevant arguments passed to the relevant record type during the instantiation process. To achieve the same functionality using a class, you need to manually override the toString method with code that looks something like this. whereas using a record type, this is automatically handled. So this feature, for example, can be a great help when debugging your code. Another great feature of the record type is that you can create an object based on another object and change one or many of the new object's properties on one line of code using the with keyword like this. So this results in very clean and concise code to achieve such functionality. So in this particular case, we have a requirement to create an object for an employee that has the same first name and last name as the previous object, employee 1, that we have already created. But this other employee, although has the same first name and last name, has a different ID and salary. So using the with keyword, we can base the new object on the original object used to represent Bob Jones, and we can simply appropriately change the values for the ID property and the salary property using the with keyword like this. As you can see, the code to achieve this is very simple when using the with keyword. Great! So for more information on the record type, check out these links. All the links that are mentioned in this video have been included in the description of this video. Number 2, primary constructors. This new feature has just been included in the latest release of C#, C# version 12. C# version 12 has just been made available with the official release of .NET 8, which was released last month, November 2023. Let's go to this URL and read a bit about primary constructors. So we've seen how we can use a primary constructor using the record type, but with C# 12, we are now able to include primary constructors for classes and structs. You can add parameters to a struct or class declaration to create a primary constructor. Primary constructor parameters are in scope throughout the class definition. It's important to view primary constructor parameters as parameters even though they are in scope throughout the class definition. Several rules clarify that they're parameters. So you can see here by looking at this example that parameters are actually contained within the struct definition. This is also the case when including a primary constructor for a class. So if we look here at this example, you can see the struct definition actually contains parameters. This demonstrates a primary constructor used to initialize calculated read-only properties. The field initializers for magnitude and direction use the primary constructor parameters. The primary constructor parameters aren't used anywhere else in the struct. The preceding struct is as though you had written the following code. So this would be the old way of achieving the functionality that you can now achieve using primary constructors. The new features make it easy to use field initializers when you need arguments to initialize a field or property. So note, before primary constructors, you would probably include such parameters through a parameterized constructor, which would only be scoped to the constructor. So to make these values available to the entire class or struct, i.e. scoped for the entire class or struct, you'd perhaps use private member variables that are scoped to the class or struct. With primary constructors, these parameters are automatically scoped to the entire class or struct. In this example, the translate method changes the dx and dy components. That requires the magnitude and direction properties be computed when accessed. This version adds a parameterless constructor to the struct. The parameterless constructor must invoke the primary constructor, so that all the primary constructor parameters are initialized. You can see through this example that a primary constructor is used as a base class named bank account. In this base class, reusable validation code is included to validate the bank account number and the owner arguments passed to these parameters. So here a class named checking account inherits from the bank account base class. So when an object is derived from the checking account class, the primary constructor will accept an account number argument and an owner argument, which is then automatically validated by functionality included in the bank account base class. In this example, the line of credit class inherits from the bank account base class. This example shows how a constructor can be used in the line of credit class to pass down the account number and owner argument values to the bank account base class. So a primary constructor is not included in the line of credit derived class, but the relevant arguments are passed down to the base class's primary constructor through the relevant parameterized constructor included in the line of credit derived class. Then we have another example with the savings account derived class, which does include a primary constructor. So this gives the developer an extra design tool, and whether or not you use primary constructors depends on whether you have a requirement to do so. So very basically put, primary constructors provide added design flexibility to the developer. Number 3, list patterns. Beginning with C#11, you can match an array or list against a sequence of patterns, as the following examples show. So in the first example, the pattern matches the array perfectly, so true is returned from the relevant expression. In the second example here, the last item in the pattern does not match the last item in the array. Of course, 4 does not match 3, so false is returned from the overall expression. So false is returned. Even though the first 2 items in the pattern match the first 2 items in the array, the last item in the array does not match the last item in the pattern, so false is returned. So in the third example, even though the first 3 items in the pattern match the first 3 items in the array, a 4th item exists in the pattern, so this means that the pattern does not match the array, so false is returned. The array only contains 3 items, and the pattern contains 4 items, which means the pattern does not match the array, so false is returned. In the last example, expressions are included in the pattern for each corresponding item in the relevant array, so let's start by looking at the first expression in the pattern. Is the first item in the array 1 or 0? Yes, the first item in the array is 1, so we have a match for the first item in the array, so this first expression returns true. Is the second item in the array less than or equal to 2? Yes, we have a match because the second item in the array is 2. The second expression in the pattern returns true. And lastly, is the third item in the array greater than or equal to 3? Yes, the third item in the array is 3. The third expression in the pattern returns true. So all the expressions in the pattern return true. So this means the pattern matches the array, which means true is returned. The pattern matches the array. And that is basically how list patterns work. So list patterns are very convenient and provide concise syntax for evaluating whether a pattern matches a set of values, for example, that are stored in an array. Number 4, collection expressions. Collection expressions introduce a new terse syntax to create common collection values. Inlining other collections into these values is possible using a spread operator. Let's look at a very basic example to help us understand collection expressions, which is a new feature introduced in C#12. The following examples show uses for collection expressions. You can see here we have created a jagged array by adding 3 individual one-dimensional arrays to the jagged array. And we can use a nested for each loop to print the individual items in the array to the screen like this. Now in this example, we can write similar code, but we are inlining elements from multiple one-dimensional arrays into one one-dimensional array. We are using the spread operator to do this. You can see that in this example, we only need one loop in order to print the individual elements of the array to the screen. We don't need to use a nested for each loop because we have used the spread operator to create a one-dimensional array based on 3 other one-dimensional arrays. We were able to achieve this by appropriately using the spread operator like this here. Excellent. Number 5, generic attributes. Lastly, I'd like to briefly look at generic attributes that were first included in C# version 11. You can declare a generic class whose base class is system.attribute. This feature provides a more convenient syntax for attributes that require a system.type parameter. Previously, you'd need to create an attribute that takes a type as its constructor parameter. And to apply the attribute, you use the type of operator, like this. Using this new feature, you can create a generic attribute instead, then specify the type parameter to use the attribute. You must apply all type parameters when you apply the attribute. In other words, the generic type must be fully constructed. So, from C# 11, using attributes with generics is now more consistent with how generics is applied in other C# code. So, this is a definite improvement for including generics functionality with attributes in C#. So I hope this has at least given you a basic insight into the types of new features that are continuously being added to the C# programming language. You can very easily dismiss these new features as just code sugar and rationalize this as why you don't need to learn the new features. But I encourage you to keep up with these new features because you should at the very least be able to recognize what other developers that you may work with who have adopted these new features are trying to achieve in their code. This can make you more efficient as a developer when working with other developers. These new features in many cases also provide you with the ability to create less code while leveraging more power. If you want to go into the delicious detail of what we have discussed in this video, I've included all relevant links below in the description of this video. I hope you enjoyed this video. If you liked this video, please hit the like button and please consider subscribing. Please also ring the bell so that you'll be notified of future content. Please feel free to share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, you can do this through my Buy Me a Coffee webpage at this URL. It will of course be greatly appreciated. I love reading your comments, so please feel free to engage with me in the comments section. I've recently joined X, formerly Twitter, so it would be great if you followed me on X. My username is @GavinLonDigital. I hope to see you soon. Thank you, and take care.